Problem number 23rd. The linear density of a string is 1.9 multiplied 10 power minus 4 kilogram per meter. A transverse wave on a string is described by the equation y equal to 0.021 meter sine of 2 per meter x plus 30 per second t. What are the wave speed and the tension in the string? So here we have to answer for two questions. We have to give the answer for the wave speed as well as we have to give the answer for the tension in the string. And also they gave the value for the linear density. First of all, let's write the given first. So what is given in this question? The linear density mu value is given. So the value of the mu 1.9 multiply 10 power minus 4 kilogram per meter. And also they gave the wave equation. So the wave equations they gave here as y equal to 0.021 meter sine of 2 per meter x plus 30 per second t is the wave equation. So here we have to give the answer for the wave speed. So the first question we have to give the answer for the speed of the wave, and the second question we have to give the answer for the tension in the string. So for that I have to compare the given equation with the standard wave equation y equal to ym sine of kx minus or kx plus omega t. So here the wave is moving in the negative direction of the x, because as we already studied in the theory, if you got the sign as negative, the wave is moving in the positive direction of the x. If you got the sign as positive, the wave is moving in the negative direction of the x. So that is not an issue here. So let's compare the term. So here the amplitude ym here is 0.021 and the angular wave number here is 2, and then the angular frequency omega here is 30 per second. So now by using these omega and k, we can easily find the answer for the speed of the wave. So as we already studied, the speed of the wave, which is given by the rule v, which is equal to frequency multiplied by lambda, but in the shortest way. So how we can find? For finding this frequency, we can derive the formula for the angular frequency omega, which is equal to 2 pi f. Therefore f, which is equal to omega over 2 pi. And also in theory we studied the concept of the angular wave number k, which is equal to 2 pi over lambda. So if you rearrange this equation in terms of lambda, lambda equal to 2 pi over k. So now you can see I'm going to take the value of f, I'm going to take the value of the lambda, and I'm going to substitute this f and lambda here. Once you substitute, we will get the answer for the speed. As in place of frequency, I have to substitute omega over 2 pi multiplied by lambda here is 2 pi over k. So 2 pi over k. So 2 pi get cancelled with this 2 pi. So therefore we can use the formula here as v equal to omega over k. So now what I'm going to do, I'm going to use this formula for finding the answer for the first part. So in the first part, they ask you to find the answer for the wave speed. So therefore, so in part A, so the wave speed is given by the rule v equal to angular frequency divided by angular wave number. So here in the given equation, we already have the value for angular frequency. So here the angular frequency omega here is 30, and then the angular wave number here k is 2. So when you divide 30 by 2, we will get the answer for the first part as 15 meter per second. So this is the answer for part A. I hope you understand the first part. Now for getting the answer for the part B, we have to find the answer for the tension. As we already studied in the theory, the formula for finding the tension is given by the rule the speed of the wave on the string is given by the rule root of t over linear density. So here we have to rearrange this equation in terms of tension. So for that, what we have to do first of all, we have to discard the square root. So for that, what I have to do, I have to squaring this equation both left hand side and right hand side. So if you square this term, left hand side you got v square, right hand side we got t over mu. where T is the tension, mu is the linear density. So now we can easily rearrange this equation in terms of tension. So therefore, tension T equal to V square multiplied by the linear density. So here the V value is nothing but the answer what we got from the first part. So what we got in the first part, we got the speed as 15 meter per second. Therefore, T equal to 15 square multiplied by the linear density value. So we have to go back to the question. So in the question they gave the value for the linear density as 1.9 multiplied 10 power minus 4. So I can substitute the value here, 1.9 multiply 10 power minus 4. So when I multiply this 15 square with 1.9 multiply 10 power minus 4, we got the answer for part B as T equal to 0.043 Newton. So this is the answer for part B. That's it. Thank you.